Hello, this is Patricia from BigSibTutors. Today I'm going to be going over a question from the June 2023 Physics Regents. It's a four-part question from the third section, so let's just get right into it. So the question reads, starting from rest at the top of the slide, a 40-kilogram child accelerates uniformly along the surface of a 4.2-meter-long slide at a rate of 0.30 meters per second squared until she reaches the bottom of the slide. And then they want us to calculate the speed, their kinetic energy, their gravitational potential energy, and the total amount of mechanical energy. So whenever you have a mechanics question, you want to first identify the variables that they're giving you in the content of the question. So by that, I mean looking for every number and then deciding what variable are they talking about. Are they talking about velocity? Are they talking about acceleration, mass, all of those variables that you're going to see on your reference table. So going through, I see a 40-kilogram child. So this tells me that M is 40. Accelerates uniformly along the surface of a 4.2-meter long slide at a rate of 30 meters per second squared. That means that acceleration is 0.3. And then this is how far she's sliding. So that would mean that the distance that she's going is D is 4.2 meters. And the reason we do this is because if you know exactly what you have and what you're looking for, it can help you identify what formula do we need to use. For example, this first question, we're calculating speed. Speed is velocity. So that means we need to find a formula that connects V, D, A, and M. So I'm going to find the reference table. Okay, so I'm seeing this first one needs T. We don't have T. We don't have T. This one is T. So we can't use any of these. T again. Here we go. This one right here has velocity, but it has no time. So this is going to be the formula that we're going to use for this first question. So we've got final velocity squared is equal to the initial velocity squared plus 2a. And actually, this is reminding me that we missed one. Starting from rest, that means that the initial velocity is 0. That probably should have been included when we first did the process. So we've got VF, that's what we're looking for, is equal to 0 squared plus 2 times 0.3 times 4.2. And because I labeled all the variables, I'm just pulling these in and substituting them into the equation. So in the calculator, 2 times 0.3 times 4.2, that is 2.52. So that the final velocity is the square root of 2.52, 1.59 seconds. So for a velocity, this would be 1.59. We're going in meters per second. Done. So next question. Calculate the child's kinetic energy. So now we're not looking for V, we're looking for KE. So I'm going to once again go to the reference table and find the formula that is KE. It is right down here. KE equals 1/2 mv squared. So you might notice how we didn't use m in the first part, where we were saving it for this part. So we've got 1/2 m, and then we just found the velocity. V squared. So our kinetic energy is 50.6. Units for kinetic energy are, so we've got 120. This is 40 kilograms. So that's kilograms times meters squared over seconds squared. But I'm pretty sure that is just the same thing as kinetic energy is measured in joules. So now on to the next question. Determine the total gravitational potential energy. So now I'm going to go back to the reference table and find potential energy. You might think that it would be this one, but this is only to do with springs. Yeah, so it will be this one here. The change in potential energy is mg delta H. So delta PE equals mg delta H. So they're asking how much was gained. So that's asking for the change in potential energy. And we're going to climb 1.5 meters vertically. So that is the change in height. So this would be 40. G is the constant for gravity, which is 9.8. And then height, of course, is 1.5. So we would do 40 times 9.8 times 1.5, and we get 588. Joules. So now they're asking, determine the total amount of mechanical energy that was lost. So basically, when the child was at the top, he had 588 joules. And then by the time he got to the bottom, he only had 51 joules. So the amount of mechanical energy lost is equal to the potential energy minus the kinetic energy. So that would be 588 minus 51, and you get 537 joules. For every one of these questions, there could be a little bit of differences in rounding. So the Regents accounts for that. So this might not be the exact answer in the book, but they'll give you leeway in terms of your answer. So all these answers would be acceptable. I would say the most important thing about these kinds of questions is actually this first step of identifying all of the variables. Because once you know what everything is, all the questions are just straight substitution using the formulas in the reference table. All right, well, I hope that was helpful, and I hope you have a great day.